Today we're going to learn how to graph exponential functions. Just a quick review on the format of an exponential equation. We start with y, which represents our total value, and that's equal to our starting value, otherwise known as initial value, multiplied by your rate, which is what's happening every time a time period passes, to the exponent of x, which represents time itself. This looked like y equals a times b to the x power when we saw it last. And we're going to jump right into our first exponential situation. We have y equals 3 times 2 to the x power, which could represent starting with $3 and doubling our money each day. We start with 3, that's our initial value. We're doubling our money each day, which means our money is getting multiplied by 2. That's where we get a rate of 2. And then x, our exponent, will represent the number of days. So on the starting day, we call that day 0, because really we haven't started doubling our money yet. On day 0, how much money do we have? Well, it tells us right in our situation that we start with $3, so on day 0, we have $3. What happens when you substitute 0 in for x in our equation? Well, when I simplify this equation, of course, according to order of operations, I have to do exponents before I multiply. So 2 to the 0 power, just like anything to the 0 power, is 1. So really I have 3 times 1, which just equals 3. On day 0, we have $3. That just backs up what we said before. What about on the first day after our experiment has begun, which we call day 1? So this is after 1 day has passed. When we substitute 1 in for our exponent, again, we have to calculate exponents before we do any multiplication. So 2 to the first power is, of course, 2, and 3 times 2 equals 6. This tells us that 1 day after our experiment started, we have $6. And I could continue to plug in my exponents, right, to substitute the number of days in for my exponent and calculate out each point. If I substitute 2 in for x, right, on day 2, or 2 days after we started, 2 to the second power is 4, times 3 equals 12. On day 3, 2 to the third power is 8, multiplied by 3 is 24, and of course that pattern's going to continue. So the day number, right, 0, 1, 2, 3, 4, paired with the amount of money we have that day, represents the points on our graph. So we have the points 0, 3, 1, 6, 2, 12, 3, 24, and so on. But over here in the money column, you can start to see where the rate comes into play. 3, then 6, then 12, then 24, then 48. Every single day we're multiplying the amount of money we had before by 2. So let's take those points and let's actually put them on a graph. We're going to let the x-axis represent the number of days. The x-axis almost always represents time in a situation, like this one anyway, and the y-axis is going to represent the amount of money we have in dollars. So like I said before, we can start putting those points on our graph. On day 0, we had $3. After 1 day had passed, if we plugged 1 in for x, we had an outcome of 6. So after 1 day has passed, we have $6. After 2 days had passed, when we substituted 2 in for x, we were clear up at $12, which is right around here. And then on day 3, we were clear up at $24, which is clear off my page, so we won't worry about putting a point there. But you can kind of see where your line is going to go. right? This is definitely not a straight line. This is going to be an exponential curve, but in order to graph the whole thing, we need to do a little more digging. Let's say that we're going to graph the whole equation, not just the positive half of our graph. And that's going to happen almost always when you graph an exponential equation. You have to graph the whole thing, not just part of it. So first of all, let's put the points on the graph that we already had. 3, then 6, then 12, then of course if we had room, 24 and 48 and so on. That means that as we move from left to right on our graph, our y values are being multiplied by 2 every time I advance one x value. That's because 2 was our rate. Well, because I only have the right half of the graph and I need to know the left half can get a little bit tricky. As like I said, move from left to right, we multiply by 2. Wouldn't that mean that if I go in the opposite direction, I divide by 2? Look at going from 12 to 6 and from 6 to 3. Moving in the opposite direction, we're dividing by 2. That can help me continue or extend my graph to the left. So if I take a look at what would come before 3, right? If I divide 3 by 2, that means when x is -1, I'd be at 1.5. Also, I could plug -1 in for x in my equation and get that same result. If I divide 1.5 by 2, I get 0.75, which is right around there. If I divide 0.75 in half, I get 0.375. Then I get 0.1875, which would be even closer to the x-axis. And the day before that, I'd get 0.09375. So I'm going to continue. As I divide these numbers by 2, I'm going to continue to get closer and closer and closer to the x-axis because our numbers are going to get very, very, very small. But if you stop and think about it, if I'm dividing even very small numbers by 2, will it ever actually reach 0? The answer is no. So if I were able to continue to put points on this graph, they would get so close to the x-axis that you wouldn't be able to tell the difference between the two, but they'll never actually quite reach the x-axis and certainly never go below it. Since I really can't draw this very well, I am actually just going to show you the graph. This is the graph of y equals 3 times 2 to the x power. And now can you kind of see what I mean by the points get really, really close to the x-axis? So close that eventually you can't see any space between the two? But it never actually touches the x-axis, never crosses the x-axis, never goes below the x-axis. That makes the x-axis something called our asymptote, which is defined by the line that we get really, really close to in an exponential function, but never actually touch. Let's take a look at our next graph. This time, let's try y equals 2 times 3 to the x power. We're going to switch those values around and see what happens. First of all, we know that because 2 is our initial value, in a situation like this, that's going to be our y-intercept. I could also plug or substitute 0 in for x and get a value of 2 in return. So I know I have the point 0, 2. After 1 day, because our rate is 3, remember we're multiplying that y value by 3 when x, or every time x increases by 1. So 2 times 3, when x is 1, we're going to be up at 6. Then if we multiply by 3 again, we're going to be clear up at 18, which is going to be way far off my graph, somewhere around there. Of course, if going from left to right, I'm multiplying by 3, then going from right to left, I can continue putting points on my graph by dividing by 3. 2 divided by 3 would be 2/3, or 0.6 on forever. If I divide that value by 3, I'd get 0.222 on forever, repeating 2's. If I divide that value by 2, I get 0.074. Then we'd get, if I can get another point, we can get 0.025. These are going to get super close again to the x-axis, but never actually touch it, even though on our graph it's going to look like it touches. So let me show you what the graph actually looks like. Can you see that if this graph were to extend, it would cross through that point that's way off our graph? And I should remember to put arrows on both ends of my graph because this is an infinite graph. It's going to go on forever in both directions. How about y equals 6 times 1/2 to the x power? Our initial value is 6, so that's where we're going to start. In other words, when x is 0, y is 6. Now we're going to multiply by 1/2 as we move from left to right. So half of 6 is 3. Half of 3 is 1.5. Remember to only advance on the x-axis in increments of 1. Let me grab another point. Half of 1.5 is 0.75. Then our next value is 0.375, so we're down below 1/2. Then we have 0.1875 and so on. So this is going to start to get really close to the x-axis again, but again never actually touches, never crosses, never goes below. If I'm multiplying by 1/2 going from left to right, what would it look like when I divide by 1/2 going the other direction? What happens when you divide by a fraction? Isn't that the same as multiplying by its reciprocal? And I know that it's kind of wrong to say it this way, but going from left to right, aren't we kind of dividing by 2? So going the other way, we'd multiply by 2. Well, dividing by 1/2 is exactly the same as multiplying by 2. So from 6, we'd go to 12, then we'd go to 24, then 48, and so on. If we draw in the curve, and I pulled this down a little bit so you could see some more points on the graph, you can see that we went from 24 to 12 to 6 to 3 and so on. Again, as I get closer and closer to the x-axis, you won't be able to see the difference. Just make sure to put arrows on both ends of your graph. Again, because this gets super close to the x-axis but doesn't actually touch it, the x-axis, or the line y equals 0, is our asymptote. Let's take a look at one more. This time let's take a look at the graph y equals -2 times 2 to the x power. -2 is our starting value, or y-intercept, and 2 is our rate. If I start at -2 and multiply that by 2, what's our next y value? Isn't -2 times 2 -4? And -4 times 2, oops, didn't quite grab that point. And -4 times 2 is -8. And then on the next point, I'd be clear down at -16, right? Well, if I multiply by 2 going from left to right, then going the opposite way, we're going to divide by 2. -2 divided by 2 is -1. Then we'd go to -1/2, -1/4, -1/8, and so on. So again, we're going to get really, really close to the x-axis, but this time the whole graph is underneath the x-axis. Let me draw in the actual graph. I moved it up so you could see some more points. You can see though that our y-intercept is still at -2, and moving from left to right, we're still multiplying every y value by 2. This graph still has an asymptote as the x-axis, right, at the line y equals 0, because it still will never actually touch that x-axis, even though it looks like it will. Okay, I think that's enough for today on graphing exponential functions. Remember, you can rewind and look through examples again if you have any questions. But for now, I wish you a great day, and I'll see you next time.